All right, here we go. We've learned two ways to prove triangles congruent, haven't we? We just finished talking about going over that homework. What are the two ways? One way, what was the first way? Well, that's one of the ways. It wasn't the first one, but side, side, side was the first one we did. Okay, and the second one was what? Side, angle, side. Okay, so we've learned two ways to prove triangles congruent. So we didn't have to show all 6 parts, right? We didn't have to show all 3 angles and all 3 sides. Okay, if you just show 3 sides and that's it, you can show the triangle's congruent. You know what I mean by show 3 sides? Show 3 sides of one triangle equaling 3 sides of another triangle. If I can do that, then I can say the triangles are congruent. Another way, if I don't want to show all 3 sides, if I show 2 sides and an included angle, what does that mean when I say it's the included angle? It's in between, okay? It has to be in between. Everybody got that? So if I show 2 sides and the angle in between those 2 sides equal on one triangle, also equal on another triangle, then I can say the triangles are congruent. Okay, we're going to learn 2 more ways today, and they're really close to these. These right here are postulates. We just accept these without proof. Okay, we just accept it. Somebody told us, okay, and it's true. These next ones are called. Let me make sure I'm right on this. I want to make sure. And oh, that's a postulate also. I think the second we do is a theorem. Yep. The next one we're going to do is also a postulate, and then the fourth one we're going to do is a theorem. All right. So let's talk about the third postulate, and I'll actually put this in here, and it is angle, side, angle. So these are all postulates that are all accepted without proof. All right, so let's just do a little example of see how we're going to use this. Make this just a little bit bigger. Copy and paste it. All right, so here are 2 triangles. Now, if I copied and pasted it, you know they're already congruent, but let's see what we have. Let's just call this ABC, and let's call this one XYZ, just to be a little different. And let's change colors. Let's go orange this time. All right, here's a situation where we would use angle, side, angle. So let's say they told you that angle A was equal to angle X. Or you could figure it out some way, all right? But you knew that angle A was equal to angle X. And you also knew, let's say, that AC was equal to XZ. All right, everybody watching? Got a couple people with their heads down. I'd appreciate it if you put your head up and pay attention. I got 2 right there. Could somebody get their attention? Heads up, please. Thank you very much. All right, here we go. So watch. If I was told that I have an angle equal to an angle here, and a side equal to a side here, and an angle right here, look what I have. I have an angle, and what else? I have a side and a angle. Now, what must be true do you think about this side? The side has to be where? In between the 2 angles. Everybody see that? So this side right here, if I'm going to go angle, side, angle, if I'm going to use that as a reason, the side is the side that's between, or the included side. Right? When I say included, that means it's the one in between. Everybody understand that? I've said that word several times now, so it should be sinking in now. So I've got an angle, I got a side, and I have another angle. What if I knew that? Is that angle, side, angle? No, it's not. Why not? Why is this not angle, side, angle? Because it's not in between the 2 equal sides. That's right. Okay? Everybody see that? So if I have the side that's in between, I would call it angle, side, angle. But watch this. These are postulates. I can't really prove it. But let's keep the side where it is right here. We just said that we can't do this because we can't say it's angle, side, angle because the side's not in between. But there's something else that we learned. If I have 2 angles of one triangle equaling 2 angles of another triangle, what do you think? It's the third angle theorem. That's right. Okay. So if I have 2 angles of one equal to 2 angles of another, then the third angle must be equal. Remember that one? That's the third angle theorem. Because you're taking the same 2 angles away from 180, so you'll get the same degree, won't you? All right. Now look at this. I didn't really change anything, right? They didn't give me any new information. I just figured that out on my own. I figured out that if I have two angles equal to two angles, the third angles have to be equal to each other. Okay. Now look at what I have now. Now I could go what? Angle, side angle, couldn't I? Everybody see that? I wasn't really introducing any more new information. Okay, all I did was recognize that this angle B is equal to this angle Y. So I recognized that these two angles were equal to each other, and then I looked at it, I'm like, hey, wait a minute. Even though it wasn't angle, side angle to start with, right, because this side wasn't in between those two equal angles, I figured out that this angle is equal to this one, and now look at it. Now it is angle, side angle, isn't it? Everybody see that? So that's kind of a theorem. We kind of did, that's almost like a little proof that we just did right there, just to show you that that was true. So here's the fourth thing. Let's keep this color coordinated here. Watch, here's the fourth thing, and this is a postulate. This is a theorem, not a postulate. What do you think I would call this? I wouldn't call this angle side angle, would I? But these two triangles are still congruent to each other, because remember, B and Y must be equal to each other, so I could go angle, side angle. Yep, the triangles are congruent. But instead of doing that, instead of saying that this angle is equal to this one, instead of that extra step, I could just look at what I have right here and say, hey, look, they're congruent to each other anyway. So I don't have to go angle, side angle. I could go what, Sean? You just said it. It's angle, angle, side. That's exactly right. Okay, and that's a theorem and not a postulate. So it's angle, angle, side. So I don't have to show that angle B is equal to angle Y and then say angle, side angle. Now you could do that if you wanted to, but you don't have to. All you got to do is say, hey, look, if I have two angles on one triangle equaling two angles of another triangle, and I have a non-included side, the one that's not in between, okay? So if I have a non-included side, I can still say that these triangles are congruent, but not because of angle, side angle. I wouldn't use angle, side angle on this. What would I use for this? Angle, angle, side. And what does this say? Look at this. The two angles are next to each other, but the side is not, right? The side is not in between. Everybody see that? So the side is outside the two angles. So here's two angles, and here's a side that's not in between the two angles. So it's very, very close. Okay, angle, side angle, and angle, angle, side are very, very close to each other. Because look, you got two angles in one side, don't you? It's just the order. That's all it is. So if you had something like this, you would say angle, angle, side. If you had something like we had earlier with the side in between, then I would say what? Angle, side, angle. Okay, it's a very subtle difference. It's not a huge difference. In fact, this is taken from this, right? Wouldn't you agree? Because we said, okay, if these third angles are equal, then look, these triangles are still congruent because of angle, side, angle. It all depends on the information that they give you and the information that you mark down on your paper, on whether you use angle, side, angle, or angle, angle, side. I know it seems a little confusing, a little weird. I'm throwing out all these A's and S's, angles and sides, but you got to keep this, you got to keep it straight. What's that? No, there's not. It's a good question. There's not an angle, side, side, okay? And it's not because if you put the letters all together, they make a word that we're not supposed to say, all right? I mean, that's a fortunate thing for us that we don't have that, but that's not the reason. It's just, it just won't work. There are proofs, and there are ways we could show you why it doesn't work. It gets a little confusing, so I usually save that maybe for an honors class or something like that on showing you why there is no angle, side, side. It's not just because it makes a word we're not supposed to say. All right, it's just because it doesn't work. All right, so there is no angle, side, side, or I'll write it like this. There is no side, side angle. All right, I won't write it the other way. All right, but anyway, so there is no side, side angle. Everybody see that? The only time you can have two sides and an angle would be when what? If it was a side, and where was the angle? In the middle, okay? So if I have two sides and a non-included angle, it's not going to give me congruent triangles, okay? So this doesn't work, but this is fine right here, as long as the angle is in between the two sides. You can't have the two sides next to each other and an angle, you know, away from it, and they be congruent. It just doesn't work. All right? So really, the stuff that you're going to do today is pretty much the stuff that we did earlier with the side, 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 and side, angle, side. Except, what are you going to be looking at? you're going to be looking at these two right here. Okay, so those are the two new ones. Remember what angle side is. It's not a postulate, it's a what? It's a theorem. Okay, because we got this angle side from the angle side angle. Okay, we kind of came up with it on our own. We said, okay, if this angle is equal to this angle because of the third angle theorem, then look, I've got congruent triangles. Here's my angle, here's my side, and here's my other angle. All right, so this kind of came from angle side angle. It's not like we just came up with this on our own. I hope that makes a little bit of sense to you. All right, and the more you do this, the more you'll kind of see why it makes sense. All right, I think, let me just take a double look at this. Now, on page, write this down, on page 276, they give you all four of them all together, okay? So they're not all scattered through two different lessons, but on page 276, there's a nice little chart, okay? There's a nice little chart with all four of them, side, 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 angle, side angle, and angle, side, all right? And they give you a nice little picture explanation of all four of them. There is no side angle, so that's why it's not part of this. That's why I marked it out. Okay? See, that means it doesn't exist. Okay, that does not work. All right? Okay, that's it. I'm going to give you a worksheet, and then you can finish that for homework. It's a front and back again. And let's see. I think I'm not having you do every one of them. Let's see which problems I'm giving you. Well, I guess I am. All right, just do both sides of the worksheet, okay? It's section 4-5.